In the previous video, 3-1, we investigated this formula. This formula is to find the position of a percentile. The position of a percentile within some data. The idea is that we will eventually summarize a collection of data with fewer numbers. To make things a little bit easier, we have the position, the index of each data element. We have the index written down here. And so the data elements go from 1, 2, 3, all the way up to 23. So in other words, there are 23 data elements. The data is written in order from smallest to largest. Let us use, once again, this formula to remember what we did. Let us use this formula to find the median. The median, you recall, is the 50th percentile. The median is a number which is in the middle of the distribution. It might not be a data element, but it marks the middle of the data. So the 50th percentile, we put 50 in for P, and there's 23 data elements, and so we put 23 in for N. 23 for N, 23 plus 1 is 24. P, we put 50 for P, 50 out of 100, same as 1/2. 1/2 of 24 is 12. This is the position. Again, it's the position of the percentile. 12 is the position of the 50th percentile. The 50th percentile is the median. Position 12, the median is the number 35. The median and other percentiles will become important when we summarize our data using fewer numbers. We will use 5 numbers to summarize our data. But it could be that we wish to find other percentiles. If we are asked to find the 40th percentile of the data, we can still use the above formula. In this case, P, the percent, 40. 40 out of 100, 40%. N plus 1, the number of data items is still 23. 23 plus 1 is 24. Now, you might need a calculator to do this calculation, but it gives you 9.6. And once again, we see that we get a decimal place in our position number. Before we had a nice position 12. This time we have a position 9.6. There is no 9.6 position. There's a 9th position and a 10th position. 9.6, the 9.6 position would be referring to a number somewhere between the 9th and 10th number. Somewhere between 30 and 32 is the number we are looking for. And so how do we find this number? If you recall from the last video how we used a decimal place in the position, we would write our 9.6, we would write it as 9 plus the decimal portion, 0.6. And this would refer to the 9th number. The 9th number plus 0.6, 0.6 times the distance. The distance to the next number. Where is the 9th number? The 9th number is 30. What is the distance to the next number from 30 to 32? The 9th number is 30. 0.6 times the distance to the next number. What is the difference between 32 and 30? 32 minus 30, the distance to the next number is 2. So 30 plus 0.6 times 2, 30 plus 1.2, 31.2. The 40th percentile is 31.2. That's a number between 30 and 32. The 9.6 position, you might say. And so that's a review of how to use this formula. And at this point, you might consider pausing your video and trying some practice. Here we have some data. Once again, we have the data numbered. It goes from 1 to 25, the number of pieces of data, the number of elements, 25. And we're supposed to supply the calculations in a few examples here. In each case, the correct answer is given. What we have to do is supply the calculation that leads to the correct answer. So this will give us some practice with this formula. The median, we remember as the 50th percentile. This formula helps us find the position of the required number. We want the 50th percentile. We put 50 in for P. N is 25. 25 goes in for N. 25 plus 1 is 26. 50 out of 100, remember, that's the same as 1/2. I want to have 1/2 of 26, and that's 13. And so the 50th percentile is in position 13. Where is position 13? What number is in position 13? The number is 40. The median is the number 40. The 25th percentile, that will become a very special number for us, as will the 75th percentile. To find the location of the 25th percentile, we put 25 in for P. 25 out of 100 you recognize as 25%. N plus 1, once again, the number of data elements, 25. 25 plus 1 is 26. We need 1/4. 1/4, 25 out of 100 is the same as 1/4. 1/4 of 26. On a calculator, you can see that that will give you 6.5. And once again, we have a decimal place in the result. And we handle this by writing the number as 6 plus 0.5. Then we think of the 6.5 position as meaning the sixth position. And plus 0.5 times the distance to the next number. So the number in sixth position is 28. Plus 0.5 times the distance to the next number, the distance from 28 to 32. We can do it this way if you like. 32 minus 28. The difference between 32 and 28 is 4. And so the distance to the next number is 4. 28 plus 0.5 times 4. 28 plus half of 4. 28 plus 2. 28 plus 2 gives us 30. 30 is the 25th percentile. Next up, the 75th percentile. 75th percentile, 75 goes in for P. 75 out of 100, you recognize that as 75%. And once again, N plus 1 will be 26. This time, 75% of 26, 19.5. Again, a decimal place in our answer. In our position, 19 plus 0.5. The 19th number in the distribution plus 0.5, half the distance to the next number. The 19th number is 43. Plus 0.5. What's the distance to the next number? From 43 to 45, the distance is 2. 43 plus half of 2, 43 plus 1, we get 44. The 75th percentile is 44. These three numbers will become quite important for our 5-number summaries: the median, the 25th percentile, and the 75th percentile. It is possible, however, that you're asked for a different percentile, for example, the 40th percentile, and in that case, 40 goes in for P, 40 out of 100, times n plus 1 is again 26, 40 out of 100 times 26, 10.4. A decimal place in our answer. We write it as 10 plus 0.4, and think of this position, 10.4, as the 10th position, plus 0.4 times the distance to the next number. In 10th position, we have the number 33, plus 0.4 times the distance to the next number from 33 to 36, 3 units. 33 plus 0.4 times 3, that's 1.2. 33 plus 1.2 is 34.2. 34.2 is the 40th percentile. So I hope you were able to supply these calculations and come up with these answers as a little bit of practice for using our formula for the position of a percentile. As mentioned before, the 25th percentile, the 75th percentile, these will be important numbers for us. The 25th percentile, think of 25%. What is 25%? 25 out of 100. 25 out of 100 is the same number as 1 quarter. 25 is 25 times 1. 100 is 25 times 4. The 25s can cancel. 25 out of 100 is the same number as 1 quarter. Q1. Q1 is the notation we use for the 25th percentile. It reminds us of 1, and Q stands for quarter. The first quartile is written as Q1. The first quartile is the 25th percentile. Similarly, 75 out of 100, 75 out of 100 is the same number as 3 quarters. Q3, 3 and Q for quarter. The third quartile. Our 5-number summary will have 5 numbers, including the median, the first quartile, and the third quartile. In the last practice, we found these 3 numbers: the median, the first quartile, and the third quartile, the 25th and 75th percentiles. The median, in the data of last example, we have it repeated here. There was 25 numbers. 25 plus 1 was 26. Half of 26 was 13. The median was the number 40 in position 13. We also found that the 25th percentile was in the 6.5 position. That was the number 30. The 25th percentile we calculated as 30, and the 75th percentile we found to be in the 19.5 position, and we found it to be 44. Now, in the case you have an odd number of pieces of data, n is 25. That is an odd number. We remember we have odd numbers, we have even numbers. If you have an odd number, sometimes you can use a little trick to find the first quartile and the third quartile. instead of finding the positions as we did before, what if you just found the median? The median was in 13th position and was the number 40. Now, there's 12 numbers below the median and 12 numbers above the median. The first quartile, actually, in this case, with an odd number of pieces of data, the first quartile is the median of the lower half. The median of the lower half. Where is the middle number in the lower half? Well, there is no middle number, but there are two numbers in the middle. There's 6 numbers and another 6 numbers. 28 and 32. 28 plus 32 divided by 2 gives us the number 30. That was the first quartile that we found in the previous page on those exercises, the practice on page 66. The median of the upper half. Again, there is no middle number, but there are two numbers in the middle, 43 and 45. Since we have two numbers in the middle, we add them and divide by 2. And the third quartile in the previous page we found to be 44. It's the median of the upper half of the data. Remember, this can only be done, this type of trick can only be done if the data, the number of pieces of data, is an odd number. Let's use that trick to find the median and then the 25th and 75th percentile of this data. To find the 25th percentile, the 75th percentile is a little bit easier because n, the number of pieces of data, is 23. It's an odd number. First, we will find the median. So the median is the 50th percentile. We put 50 in for P. There's 23 pieces of data. So we have 50 out of 100, which is 1/2. 23 plus 1 is 24. Half of 24 is 12. The median is in the 12th position. The median is the number 35. Now, we wish to find the first quartile, the 25th percentile. Since there's an odd number of pieces of data, we can find the median of the lower half. There's 11 pieces of data in the lower half. The middle piece of data is the median. The median of the lower half is 26. Q1 is 26. That was a little bit easier than finding the position, using this formula to find the position of the median. We could have used this formula. What if I did? If I use this formula to find the first quartile, I'd be looking for the 25th percentile. 1/4, you remember. 0.25, 25%. To find the first quartile, I would want to find the 25th percentile, 25 out of 100. 23 plus 1 is 24. And 1/4 of 24, 25% of 24 is 6. The position would be 6th position. This method is not all that hard, but we were quickly able to get the median of the lower half. Similarly, we can quickly get the median of the upper half. The median of the upper half, the middle number in the upper half, there's 11 numbers in the upper half. 2, 4, 5, the sixth number will be 38. The median of the upper half is 38, and so the third quartile is 38. If we used this formula, we would have found the third quartile means the 75th percentile, 24th, 23 pieces of data, 23 plus 1, 3/4 of 24 is 18. The number in the 18th position is the third quartile, the number we were looking for. So in some cases, finding the median, the first and third quartiles is not so hard. And then using these three special numbers plus two others, the minimum and the maximum, those are the numbers that we will talk about next when we do a 5-number summary of our data. So if we were doing a 5-number summary of this data, we would find that the smallest number is 5. The largest number is 52. The middle number, there is a middle number in the data, 35. The first quartile, 26. The third quartile, 38. These numbers form what's known as the 5-number summary of our data.